Right. So today, just a quick thing about our sponsors. We've got Sarah Ashworth, who is a co-organizer. She can't be here tonight. She also does Leeds.js. She has sponsored the Leeds PHP. She does do Leeds.js, but also Leeds PHP. She has sponsored the venue. We also have Frog, who have the beers, and myself as well, chipped in a little bit for beers and the chip buddies. So that's my company. Without further ado, we have Glynn, who is a developer advocate from IBM, to talk about offline first applications. Glynn? Oh yes,
So, good evening everyone, thanks for coming. It's great to see a good turnout. These things don't happen by themselves, so I'd like to say a big thanks to Chris and his team for organising this stuff. They do it with the help of the sponsors and all that sort of stuff, but it takes a bit of organising. So thanks again, Chris. So my name's Glynn. I'm based in Middlesbrough in the northeast. I popped down just an hour away to speak to you tonight. I work for IBM from my house, and I work as a developer advocate for their cloud data services group or division, and we've got a bunch of products to do with big data and NoSQL and all sorts of stuff. But not especially talking about that today. I'm talking about general principle of offline first applications. Somebody said to me once that you should always start a presentation with a story. So this is me yesterday. I was in Paris airport yesterday. It sounds more glamorous than it actually is. And this is my Google Play thing on Android. When you kind of swipe left, you get this Google Play thing. It shows all the things that are happening to you that swiped from your emails and browsing history. So it worked out that I was on the way back from Paris to Newcastle, and so it had my boarding pass all ready to go. So I thought, I won't bother printing out a boarding pass. That'd be crazy in this day and age. I'll just use my phone when I get there. It'd be brilliant. So I got to the airport and opened up my Google Play app. And there it was. Everything except the boarding pass QR code, which had miraculously disappeared. Because, why this thing disappeared? Because of this thing on the top where I'd run out of mobile data, basically. I'd run out of mobile data. Google now hadn't cached the image, thank you very much. So it was gone. So then I had to go and find somewhere to print out, all that bad stuff. So this wasn't supposed to be in the presentation, but as I was waiting at the airport, I was furiously taking screenshots. Here's another example of a bad user experience from your application not working offline. So this is a native mobile phone app on the App Store, Apple App Store. A game of solitaire that you can't play unless you're connected, which is rather ironic. You want to play something on your own, and you have to be connected to everybody. There's no reason why it shouldn't work. All the resources of the application are on the device, the binaries are on the device, the pictures and the artwork, it's all there. Why on earth it can't play until it's connected? Because it wants to collect its own stats. It won't let you play, basically, unless it has the ability to collect its own data. This guy started the game here, and he did this action, and then he did something else. I want to record all that information. And if I can't record the application, this guy's not playing, right? That's how mean it is. So we all know how to build mobile web apps. There's any number of frameworks. We were speaking before this talk about the proliferation of mobile app frameworks. The front end is kind of easy to do these days. You just pick a boilerplate, and some other guy has worked out how, some other clever person has worked out how to do the CSS and the responsive elements. You just have to put the right markup in the right places. There's any number to choose from. You can jump in one camp or flip about. But that's a solved problem in terms of web frameworks. But it's not just about mobile first. It's about being offline first. So we make our websites so that they will work on a mobile. That's important. We do that with the responsive HTML and that sort of thing. But if it doesn't work offline, then you're cutting out an awful lot of time that your users can be using your website. Now, not all applications can work offline first, but there's a lot of use cases which can, and this is what we're going to be talking about today. So this is an example of an offline first application. This is the New Horizons space probe speeding past Pluto, taking pictures. It's not like a solitaire app saying, sorry, I can't take pictures because I'm not connected at the moment. It makes sure it saves them on the device being the probe first, and then it spends 18 months streaming the data back to Earth. So that's write locally first, sync it later. That's the first life lesson number one. Because out there in the big bad world, the world is cruel to your applications. You think you're online, but you might be online, you might be somewhere between online and offline. And that's a very murky place to be. If you've got a native application, there's APIs that will say, are you connected to the internet? Yes, I'm connected. Right, I'll make a request, but it may be unusably slow. You might not be able to do anything. So you can't rely on any of these status icons as to whether you've actually got a good connection. Because things break. It's scientific. There's the 8 fallacies of distributed computing. Basically, you can't rely on anything. You can't rely on that you having a connection back to the server. The only thing you can really rely on is what you've got control over, which is your the mobile device itself. So if you want your application to work offline, you can't rely on anything else beyond that. You've got to have everything on that device for your application to work. Anything else is not a given. Which is what I've just said there, but in big letters. So if you do make your application go offline first, then you get the fastest user experience you can get. If you're writing to a local database, it's always going to be faster than writing to a remote database. Your users can use it when they're on the train, on the underground, in a boat, in a submarine, wherever they happen to be, at an airport, at a check-in desk, all of these things where you might expect to get connectivity, but you can't. And writing offline first was also a big battery saver. You're not making endless network requests over flaky connections where it's renegotiating, am I on the 3G, am I on Edge, am I on Wi-Fi, and renegotiating signals and towers and so on. So your users will thank you for saving their battery too. So it does bring some user interface problems. If you're looking at an app and you're not necessarily looking at the latest data because you're not connected, then you have to kind of present that to the user in some way, which is a bit of a subtle art in its own right. There's lots of apps there that just obtrusively error when something happens. You know, say you can't. I want to tweet about something, but I can't connect it to Twitter at the moment. Well, you could just try again later. You might think it might do that, but no, you pop up saying, "I couldn't save this tweet." Well, what do you want me to do now? Yeah, you're the application. You sort it out. So, user experience design is a subtle art, not my speciality. But what should you do? How do you indicate to a user that they're looking at an old copy of the data, that a potentially stale piece of data? Still useful perhaps, but not necessarily up to date. So think about that, think about presenting it, think about the iconography you'd use and the user interface cues you would give. The big difficulty of offline first is getting the data between you and somewhere else. So if you write only offline first, offline only if you like, then your phone is a big single point of failure for your application. Say you're doing the classic to-do application. You're putting all your to-dos in your phone, it's saving very quickly on your local device, and then you drop it in the bath. Then you've lost all your to-dos. That's a bad thing. So you need to sync the data somewhere, put it in the cloud somewhere. And that is a difficult problem to do. You can write your own sync stuff yourself, and you will get 90% of the way there very quickly, and then you'll spend the next 6 months of your life working through all of the edge cases of what happens if this is modified here and that one, what if this is not modified before that, or what if the two things are modified at the same time, which one wins? So all of the edge cases and the nastiness is what is difficult. But it's a solved problem, and there are various frameworks out there which will help you. The one I'm going to talk about today is called PouchDB. It's a free open source JavaScript library and database. You can, we're going to go into more detail. It's nothing to do with IBM, by the way, it's just a thing that's out there that some nice people wrote. They don't make any money from it, it's just a hobby project, but it's a very well supported and well written project. Beautiful test suite that's run against all sorts of combinations of browsers and things it can sync with, which is very good indeed. So it's a database for your web browser. You'll be aware that there are many different storage mechanisms within within a web browser, IndexedDB and local storage and others, which are either supported or not, depending on which browser you've got. Now, PouchDB kind of patches over this by creating a simple API. If you write using PouchDB, it'll work out what your browser's got, what it hasn't, and it will store the data regardless. You don't have to know which engine it's using under the hood, or which version, and which kind of hack it had to do to get over some bug in Safari. It patches all of that for you, and you get a nice, consistent API. All you have to do is put one line of JavaScript in saying, I'd like to use PouchDB, please, and then you can start writing data. The great thing about it for this application, of course, is that we can sync our data from our local database to something else in the cloud, like CouchDB, which is an Apache, open source, NoSQL database. And PouchDB and CouchDB, you're not surprised to learn, are made from the same cloth in that sense. They sync together. They're not related. PouchDB isn't an Apache project, but they speak the same replication protocol. CouchDB has an HTTP API. Everything is HTTP in it. So it's ideal for the web, where everything's HTTP. So your browser can just make, or PouchDB can just make HTTP requests to sync data to and from the cloud. Very straightforward. And one line of code as well. It's also designed to be separated. So PouchDB is designed to be separated from the local device, and the copy in the cloud are designed to be separate from each other. And they can both be written to at the same time in different ways, and they'll sync together. So this is the difficulty of sync that I was talking about earlier. You don't want to be writing that yourself. It's a minefield. But it's a solved problem just by picking a couple of tools off the shelf. The only problem you'd have to deal with is what you want to do when two changes conflict. How is your application going to deal with it? It never throws data away. It would say two people modified the document in different ways, like Git would with a kind of merge conflict. It would say, I can't automatically merge this, but I've got this one and this one, you work it. And you can programmatically fix it. It's free and open source, so that's good. So it stores its data as a JSON, so it's a document store. So the JSON can be of arbitrary complexity. That is, as well as the native data types, you can have objects, and arrays of objects, and inside that object there can be arrays of objects, and so on. An endless bit of doom. So you just create some JSON, store it in the database, that's it. It doesn't care about the schema. You don't have to define the schema up front. You just say, here's a JSON document, and then you can put another one in which has an entirely different schema to the first one. And it won't say, whoa, this is different to the first one. That's fine. It's not even checking, in fact. So, getting started, well, it is remarkably simple, really, I think. It's amazingly simple. You just have you need the PouchDB library, which is about 150K of JavaScript, minified JavaScript. And then you need to instantiate a DB object. So you name your database. So this one's called Smart Meter, the idea of being it's collecting electricity readings offline and then syncing them later. That's the idea. So DB is now an object which I can play with. And by creating that object, it's worked out which browser it's on and what capabilities that browser's got, what version it is, and all the other stuff around it. And so it's selected a storage mechanism you don't have to care about, and it's ready to go. So then we can start posting data. So db.post, I'm going to post a JSON object of any form. In this case, I'm just storing a date. There's no date data type in JavaScript, so it's just a string. And I'm storing an integer. So there's just 2 bits of data there, but that can be as long as you like, just for brevity. And in this case, it's calling back, so it's an asynchronous operation. When I put something in the database, it calls me back later to say it's done. It's not going to spend a long time doing that, but it's important that every operation is asynchronous because it can also act as a library for remote databases where things wouldn't happen just like that. So in every case, it's an asynchronous operation. So you get a callback, you get some error, and an error of code or null, and you get data or not. Alternatively, if you're in the modern era, you can use promises too. So same operation, but then you capture the positive response with the then and the badness with a catch, and then you can chain, requests going down the way. But I'm not too worried about which form of library you use. We're just talking about the general principle of the thing here. So in that case, if in the previous example I didn't provide an ID, so the database will provide an ID for me, just to keep things unique. If you want to supply your own ID, that's fine too. You just supply it in the object, and it's up to you then to guarantee uniqueness. Same principle, and it's a put instead of a post. That's the difference. And when you want some data back, then you give it the ID and you get the data back. So it's a database, right? So you're getting one piece of data back that you didn't put in there, and that's the revision token. And this is related to, is why PouchDB is a relative of CouchDB. And this is how it maintains version control for documents where they can be modified in 2 separate ways in disconnected databases. So it uses a revision token, and there's a 1 meaning it's the first revision, and the rest of it's a hash of the content, which allows it to track change. So somebody could replicate this database, and it would also have a version 1, and then they may modify it to version 2, and this guy might modify it to version 2, and so on. So if I want all my documents back, then I can say, give me all my documents, and you'll get an array of documents back. So this is just the basic operations of a database, nothing terribly fancy here. But it's doing an awful lot of work for you that you wouldn't want to do yourself. If you want to query stuff, then you've got a bunch of options. So the primary index is what we were using before. You pull things back by the ID, and if you've specified an ID, if your ID is something meaningful like an ID of a user, then that's fine. Pull things back by the ID, or ranges of IDs is good for streaming things between that key and that key. If you want to get do more complicated things, then you can do MapReduce. This is again a thing that's come from the CouchDB world. You basically provide a function in JavaScript and say which bits of the object do I want to index. I want to index the first name and the last name, and I'm interested in the amount they spend, say. So then it would create a key based on first name, last name, and the value. And then you could do totals of the values by first name, something like that. So MapReduce is used for summarizing data, for querying subsets of the data by any key that you want. And the keys can be compound keys, and you can get quite complicated and do groupings within those keys as well, beyond the scope of this presentation. But there are also plugins. PouchDB has a really nice plugin mechanism where you can use third-party libraries, plug them into the framework, and then you get extra functionality that either other people have written or in this case one of the authors has written. So there is a find plugin which implements a query language not unlike MongoDB's query language, where you specify a query in a JSON format with a selector and which fields you want back, and you say, oh, the selector wants to be find me all the things where the date is less than this, and you can formulate quite complicated queries with ands and ors and that sort of thing. But the language isn't SQL, but it's not far off it. So that's the find plugin. And the quick search plugin is a Lucene-style free text search index, which just by including an extra bit of JavaScript and adding that to the PouchDB object, we've got that there to do, so people can search there. their documents. That's what I've just said, but written on the screen instead. So that's a typical, well, a simple query. So the selector is the equivalent of a where in SQL, and it can contain nested ands and ors and that sort of thing. But it's quite readable, finding things where the name is Mario and the debut is greater than 1990. And I only want 2 of the fields back. I don't want the whole object. I only want 2 of the fields of a complicated object. And I also want to sort the result set by last name, and that can be ascending and descending and all that sort of stuff. So Cloudant, which is a superset of CouchDB, similarly has the same query language, and they're based on the same tech, which has been open sourced and given to CouchDB. And PouchDB has the same sort of tech too. So you can do the same queries on the server side and the client side. So replication, this is where things get interesting. So you can create data. Your web application, when a form is completed, it writes the data, formulates a piece of JSON, writes the data locally in your browser. It's always going to succeed because it doesn't have to go over the wire to get it. So then you don't want that single point of failure to be, dropping it in the bath thing. So you want to replicate the data somewhere. So you can replicate the data to any Couch-like thing that speaks the CouchDB replication protocol, and that is download CouchDB, put it in the cloud somewhere, and point PouchDB to it. So in this case, I'm saying a remote DB is a new PouchDB object, and here's the URL of where it is. So there's a domain name and the database where you want to sync with, and then you just say, I want to replicate my data to that database, and that's it. So it's a one-liner to replicate data, and that's, if you've already done it, it'll carry on from where it left off. And if you want to, I think the next slide, stop talking about what's on the next slide. The next slide shows you bidirectional replication, which is basically just say replicate this to that, and also while you're at it, replicate this to that, and do both simultaneously. And then you've got sync, and that's just a one-liner as well. You can also watch the changes come in, so if you want to do some sort of progress indicator in your UI, saying, whoa, changes coming in, make something spin on your user interface, that's fine too, and it'll also call you back when it's finished. So, and you can also get this thing, have I done that on the next slide? No, but you can also, by providing options into the sync call, you can say, make it continuous. So I always want my changes to at least attempt to be replicated to the cloud as they're done, and any changes that are written to the cloud copy want to come to me as soon as you can earthly do it. Basically, that's continuous mode, which is always attempting to connect. By default, the sync without that option will just do it once and then complete, and that's it. So that's the equivalent of kind of pressing a sync button, watching a progress indicator go to the end, and then saying, right, I'm done. You press sync again next time you want to save stuff, which is fine too. If you just want to monitor the state of a remote database, then that's simple too. You just you've got your remote database, and then you can just watch the changes come in, and you'll be pinged every time a remote document changes, and you can modify your UI to reflect that. So that's really cool for near real-time stuff. And there's plugins for all sorts of frameworks, all your favorite ones like Ember. Any Ember fans out there? Angular and Backbone, and I'm sure there are others. I'm sure while I've been speaking, another 3 have been published. And these are probably unfashionably out of date, and I can only apologise for that. So just a brief thought on Apache CouchDB. So it's an Apache project, it's open source, it's free, you download it, and you can run it yourself. It's a JSON database with an HTTP API. You can read and write data to it using anything that can speak HTTP. And because it could speak nicely to PouchDB, it's a good choice to be the thing that you sync to. So CouchDB at the moment is on version 1.6 something, which is a single node database. very soon, version 2 of Apache CouchDB will be out, and that's a multi-node distributed database. As many nodes as you like in a dynamo ring, so you can expand the ring to deal with more traffic or more data. So it's a completely different beast, really. And when that comes out, that'll be very exciting. But still, it's just it will still be just a endpoint that you can sync to. So it speaks the same replication protocol. So the relationship between CouchDB and Cloudant, which is the IBM property, is that Cloudant forked CouchDB, made it multi-node, so that it became a big distributed database. And we run it as a service for free on a metered basis and as a dedicated paid-for solution. But we've kind of open sourced a lot of the tech. So all the multi-node stuff has gone back into open source. The search technology has gone back. Some other stuff, MongoDB queries. We just open sourced the Lucene search stuff this week. There's not much in Cloudant that's unique that you can't get by installing Apache CouchDB 2, which isn't out yet, but it will be soon when you're watching this. In a few years' time, it'll already be out. So the only difference is Cloudant, we run it as a service. You have to install the stuff and deal with the hardware and watch it 24/7, that sort of stuff. So yeah, PouchDB replication, one ways, two ways, or both ways. I think I've said that already. Yeah. So once again, don't write your own syncing thing. This is so much more sophisticated, and very clever people have spent a lot of time solving this problem. The only thing you'd have to do is detect conflicts if two sides, if your application generates data on both sides and both the documents could be written, then you could get conflict, but in a good way, in the same way that Git does. So going offline isn't, we're creating websites here, and obviously you need to be online to download a website. So there are a couple of tools I just want to briefly skim past, which will show you how to make your website go offline. So this is Application Cache. It's been around for a while now, and it's well supported in all sorts of browsers. It's relatively simple to get started with. It'll probably bite you later when you come to want to change stuff, but certainly to get started, it's very engaging. You just define a file and list all of the assets that your page needs to run offline. You list them. It's a plain text file. It needs jQuery, it needs PouchDB, it needs this image, this bit of CSS, and so on. Nice flat text file, very straightforward. And then your browser will cache it. There's an example. You declare it in your HTML tag there. This is the path to my AppCache file. There's a simple AppCache file. I need a logo, CSS, bit of JavaScript. Your browser will squirrel that data away, and then if you magically turn your Wi-Fi off, revisit the web page, it all just works. Like some miracle. That your page will load even though it's offline, and then because your application is offline first and writing data locally, your user doesn't even know. In fact, so this is true on a mobile device. It's true, Android and iOS. And it's true on desktop browsers and iPads and everything in between. It does get a bit nasty. When you come to change. You write. Find you made a fault in app.js and you change it, then how on earth does this guy get how do your users who aren't looking online to get the new version of app.js, how do they do it? So there's the change control is a bit fruity. We probably don't want to go there, but there's some very nice blog posts on how to do it. Basically you have to change that AppCache file. The AppCache file has to look different, otherwise the browser won't notice it's changed. There is something coming, which is a bit too new to be, if you're actually being paid to program and people are expecting it to work in all browsers, then this might be a bit too new. This is Service Workers, which is a framework which allows web apps to behave more like native apps. It gives them a toolkit of things they can use that you would normally only get in native applications. That is the ability to to intercept requests back to the server, for instance. So that's what I mean by programmable cache. You know, if I make a request up to a server, your service worker can intercept the request and say, well, what shall I do with this? Should I get it intercepted and just give them the cache copy? Should I deny it? Should I give them something else? Or whatever. You can program. You put that logic in a service worker, and then your application can work offline. There are sync kind of APIs coming to be decided. There will be push messaging, push notifications frameworks, the ability for your application to detect when it's left or entered certain geographical shapes, to be able to perform background tasks. So even when you're, even though the website, you stop looking at the website, it may install a service worker background task to say, sync the data at midnight or every 3 hours go and check for the latest news and keep the app up to date. So this is going to be an interesting thing. Unfortunately, the current state of play is a little bit sketchy. So there's a site here written by a chap from Google, which shows you how each browser is managing to keep up with the latest service worker goodness. And this is the good bit of the screenshot. Everything below here is all a bit grey and nasty. So this one's nicely well supported. Promises, is well supported, but not this one. I'm not sure what it says. But further down the list, there's a big long web page of a matrix of browser versus feature, and it gets pretty grim. Basically, Safari all the way down is looking a bit bleak, which isn't great. But there's a kind of a lot of a push behind this, and I think given a couple of years of all browsers up to agreeing on something and building something, it could be a really useful thing. At the moment, you've really only, if you want something cross-browser, AppCache is really your only choice at the moment, unless somebody clever writes a kind of shim library that hides all this nonsense for you. The other thing to bear in mind is that if your web application is making requests to a server that it didn't come from, it didn't originate from, then it won't be allowed to because of the same origin policy in a browser. So if I'm a web app coming from glynbird.com, I can only make AJAX or XHR requests back to glynbird.com for security reasons, unless the server I'm speaking to waives its rights to that by putting a header in its responses saying, I will allow requests from any domain. So this is called cause, and basically in Cloudant or CouchDB you can say, enable cause from these domain names or from anywhere, and it will therefore your web app can then speak to CouchDB or Cloudant or whatever and get around that problem. If you don't do that, then it just doesn't work. So that's the end of your experiment. So yes, so once you've built your web app, you can deploy it by just putting it on the internet and let people download it and saving it as a shortcut on their phone or something, like web apps are supposed to be. There'll be various generational pushes to get web apps right up there with their native apps. It hasn't quite taken off, and therefore there's these sort of compromises. People will package a web app inside of Cordova or inside of PhoneGap, these native frameworks that package web apps as native apps. You can do that too. And PouchDB will work inside of Cordova and will store its data in SQLite in that case, and then you can store an unlimited amount of data. So that's an option too. So web apps or native, pretend native apps, it's up to you. So I'm just going to finish off with a couple of examples of, I might have to, I haven't really thought this through, so I'm just going to improvise slightly. Let's take it out of presentation mode. And, right, so I'm going to create a database. I'll just go onto Cloudant here. Just so I've got a remote target to write to. So this is my Cloudant database. Come on. And I'm going to create a new database here called Leeds. So I've got no data in it, which is fine. But I'm just going to open up its permission so it's world writable, so I don't have to deal with authentication. which is just great long usernames and passwords. So, right, world readable and writable, which is, don't do it at home, kids. So this is an offline first application, just a quick demo. So it's hosted on a web server, and the idea is, I wrote it for a colleague of mine who was at a conference, and they were in a place where they had bad network reception, but they promised to do a competition where they collected their first name, last name, email address, and do you agree to the terms and conditions sort of thing of people as they went past with a chance of winning a Raspberry Pi. So they just wanted to record this stuff and then squirrel it away and then upload it later. So basically all you do is you say, oh, well, I want a text input here, and I want it to be first name, and the label is first name, and there isn't a placeholder, and there isn't any help text. I save that there, and then another one, you get the idea. But I have to do more than one, otherwise you won't believe me. Last name. Get rid of that. So I'm just defining what the form elements I want to store, and then, you know, which prize do you want? So prize is the variable name, and it's going to be called prize. I can type there. So when I've saved my form definition, then the application transforms itself into a form with the fields that I asked for, and I can start, you know, I hand it round on the iPad to people, and I say, you know, what's your name? And they say, I like that, and they say, oh, thank you very much, and then the next guy enters. You know, this isn't rocket science. But what's going on under the hood, of course, as you might expect, is it's not storing the data on some web server somewhere, it's storing the data locally in PouchDB. In fact, I should be able to prove that to you. I should. By saying, well. So DB is a new PouchDB. I probably called it pro forma, I imagine. And then let's just see if we can get all the documents back. I want to include the document bodies, and I want you to pass them back an error and some data to a function, which I'll dutifully console log out. Right, that worked, because I've got the promise back, which I've not used, and I've also got a null and an object back with 3 rows of data, 3 objects in them, which I can make it bigger. Yeah, I apologise. Yeah, that's better. There, right, okay. There's my config special document, which contains the form stuff. And then one of these will be the submission, there, Fred Smith, option 1. So, you know, it's just some data. So I've stored data offline. And then when in the settings thing here, I can actually put in the URL of a Cloudant database, in this case, could be CouchDB. Other databases are available, /Leeds. And I say, I want to sync that data to my Leeds database. And it says, okay, I've synced it, thanks. Great. So now I go to my Leeds database, and I've got some data in here too. So it's that simple. It's not hard. It's just a one line to save data. It's a one line to sync data, and all of that magic is just taken care of for you. So that's just collecting data on the client and syncing it to the cloud. The opposite of that is this one, right? So this one is taking freely available Victorian fiction from the Project Gutenberg. I've imported it into each book into a Cloudant database or a CouchDB database, and then I've got a catalog database with a list of all the books. So when I first visit this site, it syncs the catalog to the local device, and this will work online or offline, which I'll prove shortly. And then from the catalog, I can then download an individual book. So Bleak House is a big old volume, so I'm going to sync Bleak House. And then, there we go. It's a bit more than 1%, isn't it? That's more like 10%. But anyway, you know, some data is faster than others. But the idea is that you sync the data that you want to take away with you locally, and then you can consume it offline. So I can, even while Bleak House is still downloading, I can still consume ones I downloaded earlier, for instance. It's just data. So this is the opposite of the use case we had before, where data is generated on the device and synced to the cloud. The data's a fixed set of reference data in the cloud, but you don't want all of it on the device. You just want certain portions of it, which you can optionally download. Meanwhile, Bleak House is still downloading. It's a big old thing. And finally, what was my third demo? This one. Oh yeah, right. So this guy is just a. So this thing I wrote when I was doing some work. I was creating for work, a cluster of Raspberry Pis, each with CouchDB on. So I had 12 Raspberry Pis with little lights flashing to show when they were going. And basically, because I was offline, I was on this local network which wasn't connected to the internet. I wanted to record my notes, so I created an offline first, or I'm getting it, word processing thing. So this is what I was writing at the time. So I write the data in markdown here, usually without the preview. So I'm just writing my stuff as I'm furiously trying to work out how this thing works, but I haven't got access to Google Docs, which is what I normally use. And then, when obviously you want to print it. So when you print it, it just, switch the preview off. When you print it, it shows you the beautified markdown version. But of course, you can optionally sync with a cloud copy, and other people can sync too. So other people can sync to the same database, and therefore you can share the same body of documents effectively. You can grant one guy to have read and write access to that database, and you too can have read and write access. And any changes I make will get saved to the cloud, and he'll get them too, he or she. So again, the same principle of data originating on offline first works best when you've got data being originated or generated on the device itself. And the final example isn't I'm going to show you as such, but I'm just going to point you to it, which is a location tracker. So again, this is is where data is originating on the device. So this is a kind of bit like a fitness tracking application. It uses the GPS of your mobile phone, just through HTML5 APIs. It tracks your location as you run around the block, stores that as a route in a JSON document, and then syncs it when it can. If it can sync it on the mobile network, that's fine. But if it has to wait till it gets to Wi-Fi, that's fine too. So, you never don't save it. You don't say, sorry, you're going to have to do that run again because I couldn't connect to the cloud at that instant. So it's best to always save the data first when you know it's stored. So this application is in a tutorial, and if you're interested in creating a offline first application, you can start there, and it works its way up from a simple HTML app through to an Angular app and all sorts of some Node.js authentication layer and all sorts of stuff. But one of Cloudant's customers is Runkeeper, the fitness people, and they have millions. I'm probably not allowed to say, but lots of customers. And each one of those, the way that those sort of systems are architected is that they have one database per user, and that database is replicated between the mobile device and the copy in the cloud. So instead of having, in a traditional sort of SQL database, you'd have a kind of users table and a runs table and a join between them, and the data just keeps getting bigger and bigger. But in this sort of paradigm, you have one database per thing or per user, and that kind of isolates each user's data to one database, and that can be synced to and from the device. And even if it means having tens of millions, hundreds of millions, billions of databases. So CouchDB or Cloudant isn't afraid of many databases where others might be. So it's a great good way of scaling and load balancing actually around a large ring of databases, of database nodes. So that's me done. Just one last word is that I believe there's a monthly challenge, if you like, where the audience of this meetup is, if something you like, you see here that you like, and you want to go and build an application, then you're encouraged to do so, and then present it at the next meetup. So your challenge effectively is to go to PouchDB.com, download the code, build an offline first web app, put some AppCache nonsense at the top, and switch your Wi-Fi off and see if it works, and then demonstrate it at the next meetup. So, and the best one wins a prize, I believe.
Yes, that's right.
So that's it. Thank you very much.
The permissions or the security between the client and the server.
Yes.
I saw a line on that last slide, which was a Node.js, I assume some kind of proxy.
Yes.
Is that how the permissions are managed? So it has to go through something in the middle.
It doesn't have to at all. No. I mean, in that case, in that application, it shows you how you could do it like that if you wanted to. But Cloudant is built, you know, and CouchDB is an HTTP API. It's designed to speak to without a middle layer, effectively, if you can get away with it. So therefore, the permissions you're working within the permissions model of CouchDB, which is kind of per database. You're saying this database, this username and password has access to this database, which is why people split their databases up into one user per database, so that one runner can't see another runner's data. So the keys are given reader or writer access, or replicator, or something else, an admin form. But basically, an app would have to say on registration, create a database for one person. Create an API key that has access to that database, and then transmit it down to the app, which would store it locally and say, okay, I've got my API key now. Nobody else would know it, and that would only give him access to that database.
And what about the aggregation between those databases? Is that done somewhere else? Is that pushed to another service that
I see. Those databases wouldn't replicate together, so there wouldn't necessarily, by default, be a big mega database with all the data in it. They will remain as separate databases. I mean, you can script it to say, take all of my 30 million databases and replicate them into a 30 million a month database, which has got everything in it.
yes.
But that would be extra work. That doesn't happen for free. And, but you can do different things. You could say, I want all my stats, all my usage stats to be in monthly pots. So this is the March pot, this is the April pot, and there's 50 billion things in there, and then there's 50 billion things in there. Then you can just sort of delete that database and stick with it. All sorts of things are possible. Good question, yeah. Or you write your own middle layer, and then you're routing all the traffic through a middle layer, and then points.
About the HTML5 application offline cache. Could you explain a bit how the versioning works with that? Because I've got one of my apps at work, it has a few hundred users that use the same app multiple times a day. And we'll let them just do basically pointless traffic, so not in updates for every user. So we'll be able to do something.
Yes.
And we end up with probably gigabytes of data, wasted data really, just loading the same files over and over again. And that looked really interesting. We do a lot of versioning problems. So.
Versioning is difficult. It certainly helps if when you change say a JavaScript file changes, it would be helpful if the name of it changed. And then your build tools like Grunt or whatever you build your AppCache file with, you'll recognize that the name has changed. Because the actual content of the file has to change. Basically, once the thing is cached, you can programmatically say in your web app, just go and check whether the AppCache has been updated. And if it has, prompt the user to say, there's a new version of the app, do you want to download it? Which kind of triggers a full page refresh. Yeah. But only if it has changed. So, which is really handy. But it's quite crude in that the file content has to change. Even if the file itself, the contents of the file have changed, it won't know. And you'll be stuck in this loop of, I can't get the latest version.
You're using like query strings or something like that?
You could use it. Yeah. It's quite a subtle. There's blog posts on it which will show you the horrors. But put simply, if the file name changes, you've won. But
so if you fingerprinted in that case,
if the file was a hash of its contents or something like that, then you probably need some build tool mechanism to automate that. Because it's very easy to release an app and forget to do it, and then the people stop.
Well, Ember CLI does that automatically, and I think Angular 2.0 will have it as well because it's using Ember CLI as well.
Yeah. There's some gotchas in there. I should dig out the blog post, but why AppCache sucks or something, just Google it. But there's certainly some gotchas there. But it's a very powerful way, certainly to limit traffic, pointless fetches of. You can also cache things from other people's servers. So if you're getting, say, jQuery from a CDN, then you can put the full URL of CDN or Bootstrap or whatever it is, and those will be cached too. So it's not just stuff from your web server. It's anything that your application needs to be able to do its job.
Thanks.
You mentioned that the database that's on the server needs to use the CouchDB replication protocol.
Yes.
Are there any implementations of that for traditional relational databases in case you wanted to build a mobile app for an existing system?
I don't think that there are. I mean, there's ways of getting data from. Oh, hello.
I know of one of them that's in. I'm not sure how ready it is for release, but I know of one of them that's on a CouchDB layer for Drupal.
Oh, right. Okay. Yeah.
Which will be used as part of a content staging from one CMS platform to another.
All right. I mean, it's tricky because you go from a NoSQL database to a SQL database. If it's very flat JSON, then that's quite easy. Just it's one-for-one mappings, field to field. But if people start using arrays of something, and it can get quite nasty. I mean, I've written stuff where it takes a JSON object and turns it into text files and imports it into a data warehouse with flat tables. So it's possible, but I don't think there's anything off the shelf that says turn Postgres into a replicatable thing. I mean, that's really, yeah. I think
What about Mongo? Doesn't do anything to...
No, I don't think it's Mongo. I mean, the only other rival services are probably things like Parse, where you can bang into a big old framework, which is lock, stock and barrel, which will do some sort of syncing between its nebulous storage engine and its library storage engine. You don't know what it is, and you can't get out of it. So you kind of locked into their vendor to work, but you have to keep paying them to do it. So you basically got to CouchDB install itself, run as a service, or there's another commercial organisation called CouchBase. They have a thing called CouchBase mobile gateways. But I think that's all CouchDB. It's no surprise. It's the only database that really does this syncing properly. It's not sync in the sense. It's not replication in the sense of master on a MySQL database. Where if two things change at the same time, that's it. Game over. Call the sysadmin. It's proper master replication.
You mentioned about conflicts.
Yes.
You could resolve them from an on-plan.
Yeah.
How would you actually do that then? How does that work?
But everything's API driven, so you in a lot of applications you wouldn't get conflicts, right? So if I was talking about a smart meter thing earlier, we're just collecting data. You're never writing over the same data. You're never changing or reading effectively, so you're not going to get conflicts. Similarly, if things happening on the server and things happening on the client are always writing to different documents, then you're not going to get conflicts. But if you do, then all that happens is inside of the document we keep both copies of the database and we kind of flag it as this one's conflicted. Then you, as the application writers, detect the flags is conflicted is true, and you say, well, which of these copies do I want to keep, or do I want to create some jumble of both, or do I want to do anything else actually? So you just basically resolve the conflict through the API saying that one's going, that one's staying, or a fourth version is to succeed. And it's the equivalent of hand merging a Git merge conflict, but you'd have to do it programmatically. You'd have to say like the latest one wins, or the manager's change wins, or something else, something algorithmic merges.
Yeah. One more question.
Yeah, I had a question. The examples you gave said, well, we're not really interested in a schema.
Yes.
But lots of applications will be, and will have some kind of validation at the remote end. So what I'm interested in is if you've got an offline application underground on a train, it could be half an hour or so before the remote server says no. So how do you, that the local application might not think anything's wrong.
Yes.
So How does that?
Well, it's true. It's
Make
good.
it a good
You raise a good point. So basically, by going into the web inspector, I can put documents into the database of any form, even if it's not my application. So there's kind of a security thing going on there. But in terms of when it replicates to the cloud, you can create filters on CouchDB environment that say, oh, every document must pass this function, this JavaScript function, before they're allowed in, for instance. So it could reject documents that were bad or didn't fix it. When we say schemaless, we're not saying that your application has no idea what the data is going to be. You're sure your application needs to know what data is there. It just has complete flexibility to change that schema over time at no expense. Now, I was with a customer the other day, and they said, "Oh, if we want to change, if we want to add a column to the table, we have to give you 6 months' notice." Right, so that's bad. So adding a field or changing the schema is a zero-cost exercise because you don't have to go back and change previous documents, and you don't have to inform the database that you're going to do it. So it's purely an application level thing where you say, I want to store the age of this person, or I want to store the photos.
Yeah. What I was more thinking of was a time delay between,
Yeah.
say, you've done something at the local end and it's, say, not malicious in any sense.
Yeah.
It's just that
Just bad.
just something goes wrong, like, or there's a bug in the client program. But if you can do that, complete the operation, so as far as the user's concerned, done, I've sorted it. And then, an hour later, you come surface and
It's true.
you get
It's true.
you get an error back. How do you present that to the user and say, sorry?
It's a different way of working. It's the equivalent of I gave an example of Twitter earlier where they say, sorry, I haven't been able to send it, but you only got one option: delete the message or try again. So, and that's when it reaches the server effectively. They could one option they could have done is they said, I've saved this perfectly good tweet now, and now we'll just continue to retry it whenever I've got a good signal. I won't even tell you doing so. That's the other way of doing it. But I suppose the answer to the question is your application is a full application locally. It can do any checks it wants to on the data before it goes into the database. Bar the change the way I showed you there. But say on a mobile phone, I think there's no means into the back end. Your application is the gatekeeper to the database, basically. So you decide whether the document is written or not.
That's a trusted client.
Yeah, sure. So the database is local. There's no even in Cloudant or CouchDB, there's no gatekeeper for data. Once you've got the right access, you can write any document you like. So your application has to be trusted to be able to behave responsibly, I suppose.
Great. Well, thanks
Cool.
very much for that, Glynn.
Thanks.
Yeah. So.